Hello, welcome to university. So we're going to learn how to derive the sine rule. The sine rule is a trigonometric relationship or relation between the angles and sides of a triangle. And please take note, for sine rule, the triangles we are talking about are those triangles that are not right angle triangles. Okay? So for the derivation of this sine rule, we're going to use an acute triangle and an obtuse triangle. Acute, all sides are below 90 degrees. Obtuse contains an angle above 90 degrees but below 180 degrees. So to start, we're going to label this part, the sides. These are the angles, angles A, B, C, A, B, C. So we're going to say this side, the side opposite C will be labeled with small letter C. The side opposite B, small letter B, and the side opposite A, which is this side here, with small letter A. Same thing here we have here as A because it's opposite A, here as B, and here as C. Once we've done that, all we have to do next is to draw a perpendicular line from A down. So we have this, and we can call this place D. Same thing here, perpendicular line down. I call this D. And then this perpendicular line can be labeled with H for height. H. Now, if you observe, we now have two triangles inside these obtuse and acute triangles. Here we have angle ABD and ACD. Same thing here, AB, ABD and ACD. So with that, we can start our derivation. So we can say in angle ABD, in angle ABD, sine of B, sine B will be equal to, we know what sine is, right? Opposite over hypotenuse. What's the opposite of B? H. Over, what's the opposite of the hypotenuse? That's C. And then let's make H the sort of formula here. We're going to say H equal to C sine B. We can call that equation 1. Then we'll go for the next one in angle ACD. Let's find the sine of C here and here. We say sine C, that's big C, to be equal to what's the opposite of this? That'll be H here. The opposite of this, H here. So we say H all over. What's the hypotenuse? B. So let's make H also the separate formula here. We have that H equal to B sine C. We can call this equation 2. Now, if you observe in equation 1, our H is this. In equation 2, our H is this. So you can say equate. Let me divide this. You can say equate, since H is still H, equate 1 and 2. If you have to do that, that means equation 1 is equal to equation 2. C sine B will be equal to B sine C. And then from there, we can gather all the B's one side and all the C's one side. So we can divide here by C. It will go here, divide here by B. So at the end, when you do that, when you take like terms, you're going to have this as your final answer. Let me make this straight here. Going to have this as the final answer. It's going to be sine B all over B equal to sine C all over C, which can also be written as B over sine B equal to C over sine C. Now, this is for just B and C, but if we have to consider, we say considering A, B, and C, the final equation will be A over sine A equal to B over sine B equal to C over sine C. So this is the sine rule, or you can simply take the inverse of all of this here. It's going to be sine A all over small a, that's the side, equal to sine B all over B equal to sine C all over C. Whichever you decide to use, they are both correct. These are our sine rules. Simple, right? So all you have to do is use this when solving for angles that are not right angle triangles. And I believe this relationship will help you to get your answer correctly. So once again, thank you so much for watching. Please subscribe to our channel, like this video, comment, and share. See you in our next video.